When people hear the term artificial intelligence, they often think about chatbots or image generators. But to really understand AI, you have to understand the foundational concepts and terminology behind it. Let's start with cognitive computing. This refers to systems designed to simulate aspects of human thinking. Machines don't actually think the way humans do, but they can model reasoning patterns. They analyze information, recognize patterns, and make decisions in ways that resemble certain cognitive functions. Artificial intelligence is the broad field focused on building systems that can perform tasks that normally require human intelligence. Within AI, one of the most important areas is machine learning. Machine learning allows systems to learn from data instead of being explicitly programmed for every rule. Instead of writing detailed instructions for every possible situation, we feed the system large amounts of data and let it detect patterns. During training, the algorithm adjusts itself to reduce error and improve accuracy. Once trained, it can make predictions or classifications on new data. There are different types of machine learning. Supervised learning uses labeled data. Unsupervised learning finds patterns in unlabeled data. Reinforcement learning improves performance through feedback and rewards. Deep learning is a more advanced branch of machine learning. It uses neural networks with many layers. These networks are inspired by the structure of the human brain. Each layer processes information and passes it forward, allowing the system to model highly complex relationships. Deep learning is especially powerful in areas like image recognition, speech processing, and language modeling. It's important to understand the difference between machine learning and deep learning. Machine learning is the broader category. Deep learning is a specialized technique within it that relies on multi-layer neural networks. Generative AI is another major development. Traditional models classify or predict. Generative models create. They can produce new text, images, audio, or code based on patterns learned from training data. Large language models, often called LLMs, are a type of generative model trained on massive amounts of text. They use deep neural networks to understand context, relationships between words, and language structure. Many of these systems are considered foundation models, meaning they are trained on diverse datasets and can be adapted to many different tasks. Natural language processing focuses specifically on enabling machines to understand and generate human language. Closely related fields include speech recognition, which converts spoken words into text, and computer vision, which allows machines to interpret images and video. AI also plays a role in autonomous systems. These are systems that can perceive their environment and make decisions with limited direct human control. Examples include robotics, self-driving systems, and intelligent monitoring platforms. Finally, AI operates across different computing environments. In cloud computing, models are trained and deployed on centralized infrastructure. In edge computing, processing happens closer to the data source, which reduces delay. In IoT environments, AI analyzes data from connected devices in real time. By understanding these terms and how they connect, you build the conceptual foundation needed to navigate artificial intelligence confidently. Once you clearly understand machine learning, deep learning, neural networks, foundation models, and application domains, the entire AI landscape becomes much easier to interpret.